Let's take a look at 3D camera tracking in case study 2. As you can see here, this is a final testing render. If I just quickly play it. The reason 3D camera tracking is so important in visual effects shots, for instance, in this example, this is a handheld shot. If we want to integrate any 3D creatures or geometries into the live action plate, we need to analyze the camera movement after gaining a virtual camera extracted from the live action plate to refilm the entire scene. This is a script we created for 3D camera tracking test. We have section 1, 2, 3 for 3D camera tracking. Section 4 has been done in Maya. As we can see here, this is 3D match move. This process can ensure 3D geometries matched perfectly with the camera movement. In section 5, we can say this is the result we have tested in Maya. Okay, the geometries then eventually being placed in the 3D scene in Nuke. Then eventually apply the lens distortion before and after. Then use a merge node and integrate all the testing geometries on top of the original plate. Okay, so let's take a look at each section here. So section 1, as we can see, is titled Removing Lens Distortion. In this shot, we have filmed lens distortion, and we use the lens distortion node to remove the lens distortion information from the lens grid. If I double click the lens distortion node in the properties section, we can say if we switch to the analysis tab, and first of all you need to click the detect, then calculate it, then after that click solve. For instance, if I just quickly give you this example here. Alright, analysis tab, detect, then after that click solve. Now we can say the lens distortion is removed from this checkerboard. Okay, if you want, you can click none from this option here, before, after. So after removing the lens distortion from the checkerboard, then we can clone it, then use the data to remove this live action plate. However, you have to understand the lens grid and the plate were filmed by using the same lens, the same camera, and the same focal length. So when we remove the lens distortion from the checkerboard, we can use this data to remove the original live action footage. This is why you can say we use a clone node, here the brown line, then connect the clone node underneath this original live action footage. If I highlight it, before and after, you can say before, after, before, after. This is the result that the original lens distortion has been removed. When the lens distortion is removed from this live action footage, we can start to consider 3D camera tracking. However, if you say in the background here, we do have some moving characters, because in 3D camera tracking applications, these moving elements can really distract 3D camera tracking, which means we'll create some inaccurate results if something is constantly moving in your scene. So because of that, we use a roto node. As you can see here from the properties section, we created a couple of rough roto shapes. So this means we're going to use these masks to isolate these moving components. Then eventually, during 3D camera tracking, Nuke will ignore these moving characters. So after that, obviously 3D camera tracking, in the camera trackers tab, make sure the mask option is set to source alpha, because we do have alpha directly in the source. Okay, then that is why by default is set to something else. Okay, then after that, double check the range, that is correct. The camera motion is set to a free camera, which is correct. In this case, it's a handheld camera. Then lens distortion, no lens distortion is set by default, that which matches our situation because we removed the original lens distortion from the plate already. Then after that is a focal length. In this case, we know the focal length was set to 24. And also film back preset. If you click it from the drop down menu, we can pick up the camera used for this plate, Canon DSLR, and down here the last option is Canon Rebel 550D and video option. If you have noticed, there is another option for still images. When you shoot videos and still images, the sensor size can be different in your digital cameras. So in this case, video, then immediately you can say film back size is set to this X and Y. After that, you go to settings tab. By default is 150. You can increase it slightly, but in this case I used 1000 for demonstration purposes. Okay, then after that, go back to camera tracker tab, then start to track it, then after that solve it. We eventually got something like this. After tracking, we need to select some tracking features, then right click and set them to the ground. Okay, as you can see here, they eventually set on the grid like that with purple dots. Okay, we can clearly see that those ones are the concrete bars. Alright, then after that, in this case, the error threshold eventually is reduced to 0.57, alright, which is not bad at all. Then in the export section, switch the camera to scene, or you can use scene plus and create button here. Then eventually will produce a rig like this. Okay, and in this setup you have camera. This is the tracked camera. You can see. And also, if I temporarily disable this one, and also tracking features here. Alright. In section 3, we can clearly say we use the point cloud generator to generate the scene, as you can see here. That concrete bars, and that's the ground. Then for the point cloud generator, analyze sequence, then track points, then eventually we got this result. Then after the point cloud generator, we can generate a mesh of the scene in Nuke. After this, we use the two write geo nodes to write all those components in the scene for further operations in Maya. As you can see, for the first write geo node, we exported everything to FBX format, the geometries, cameras and point clouds, and that's the geometry, and also camera. Okay, then also point clouds are here. Point clouds. For the second geometry, we'll also add one extra option, which is a locator to define the height of the concrete bar here for this one. So when we go back to Maya, we can get a sort of brief idea of the height of this concrete bar. When we export all the components and Go back to Maya. As you can see here, the scene is loaded. In the outliner, we have new camera tracking elements. Okay. Then also we have testing geometry group, which is added those 3D geometries. If I extend the plus sign, we can say Nuke 3D tracking camera, which is this one here. That's the tracking camera. And ground, that's the mesh. And also in Maya, we trimmed those unnecessary areas. For instance, if those parts are not needed, we can directly delete them. Okay. And also locator, that's the locator we exported from Nuke to indicate the height of the first concrete bar. And tracking locators. Alright, exported. And hey, I just want to let you guys know the tracking locators as a group. If you extend the group, you can say all the different locators, all the tracking features here. Then I reduce the size to 0.01, so it won't be too large for us to say. By default, it's set to 1, like that. All right, 0.01. And inside the group, and also, another locator we created. Then after that, we need to scale up this scene to match the 1-to-1 ratio of the real world scene. So this is why we use the distance tool, which can be brought from create, measure tools, distance tool. Then to scale the entire scene up. Okay. When we scale the mesh to match the real world scales, we can clearly say the distance. For instance, here before it was like 49, roughly about 50 centimeters. In the lower right corner, if you see this little orange guy, click it and you can bring up the preferences window and go to settings. You can say by default I use centimeters, and from the drop down menu you can pick up different measurements, but I'm going to use the default centimeter in this example. During filming, we understand the height of this concrete bar is about half meter, so scale the entire scene up and use this as a reference. You can say it's roughly about 50 centimeters, which is a half meter height. Also, we added a group of testing geometries and put everything, upside down and snap them to the geometry here. So they tightly connected on the ground. As we can see here, if we play it, you can clearly see all those geometries are tightly snapped on the ground. No drifting failings at all. So this is something we want. Then after that, when the 3D match moving is finished, we can export those testing geometries out as OBJ or FBX files. Go back to Nuke. We used a read geo to bring in all the testing geometries, and in order to see them, we connect a checkerboard. Okay, then after that, we also use the transform geo. Using transform geo is to scale the entire scene down. The reason for that is because during 3D match move, we scale up the entire scene 300 units. Okay, So this is why, in order to fit with the original scale, we need to scale down. As you can see here, we need to scale down the testing geometries 300 times smaller. We can clearly see they fit seamlessly with original scene. If we highlight the scanline render, you can clearly see all the testing geometries and also tracking features, which can be disabled from here by pressing the letter D. You can temporarily disable it. Now, if we want to integrate the testing geometries with the live action footage, the original live action footage, we need to apply the original lens distortion information to those CG 3D testing geometries. So they have exactly the same lens distortion information compared to the live action plate. Okay, now we can say there is a lens distortion node being added here. This node is actually copied from the node above. Control C, Control V. This is a cloned node, which means the attributes contained inside this node is identical to these two. Alright. However, we want to disconnect the clone connection. Go to Edit, Declone. In the Properties section, under the Lens Distortion tab, in the Mode drop-down list, switch it from Undistort to Redistort. So this node will be applied to the 3D testing geometries and have the original lens distortion redistorted to them. Then after that, if I show you the difference before, after, before, undistorted, redistorted, undistorted, redistorted. Then after that, we can integrate the testing geometries into the live action footage here, the plate, using a merge node. If we play it, we can see that's the testing result. So case study 2 has introduced the 3D camera tracking, going back and forth between Nuke and Maya and back to Nuke, in order to produce, some really accurate tracking results.